Alright guys, this is a quick video on inverses. So as of now, what you guys have seen, and I asked you in class and most of you couldn't give me just a general idea of what a function is. So what a function looks like, first of all, we denote it using this f of x right here. Then it's usually equal to something, and there's many of different types of functions. We've learned all about parent functions recently, and those parent functions are used to represent different real-world scenarios. But generally, a function always has something being put into it, an input, right? Input, or your domain values, your x values that you put into it, and then out of the function comes its output, or its range, right? It's a dependent variable. So it has an input and an output. And as of now, you guys are totally used to putting things into the function and getting something out. What an inverse is used to do is, if you're only given an output, how do you trace it back and find its input? Okay, so this function right here takes inputs and gives you outputs. If we create the inverse of this function, it'll be able to take this function's outputs and give us its inputs. So there's three ways you can do that pretty easily. Three ways we're going to learn about it on this video. Just by using coordinates. We can do it graphically by using the graph. And we can do it using just basic algebra. So algebraic methods. Let's start off by using the coordinates, and this is super easy with coordinates, guys. Super easy. So a lot of you told me that the inverse was the opposite, and that's basic enough as far as this example is concerned. So if I'm going to write down, if this is f of x right here, if this is f of x, the way we write down the inverse is f inverse of x. Notice that's got a little -1 there. That's meaning that this is going to be its inverse. So if this is f of x, then f inverse of x is that same set of coordinates, except it's the opposite. So I mean, they're going to be switched. So instead of 0, 6, I'm going to have 6, 0. Instead of 1, 4, I'm going to have 4, 1. Instead of 0, 3, or 3, 0, I'm going to have 0, 3. So here's the inverse. I'm going to write it down real quick. I know my hand gets in the way, and I know sometimes these videos are jumpy, so I'm just going to go ahead and write it down and then move my hand out of the way. So that's the inverse, though. Then I need to close my set off. That's the inverse. So these 4 points, notice all my x and y values have been exchanged or flipped or switched. So my x value now becomes my y value of the inverse. So it's totally opposite. But that idea of switching your x and y value, that is what inverses, are generally all about. So if you look down here, this is how you find an inverse with coordinates. We're already done with that. You just switch the x and the y value. If you look here at the equation, to find an inverse given an equation, switch the x and y. It's the same idea. It's exactly what we did here, except now we're just doing it with an equation. Then you have to solve the resulting equation for y. So I'm going to start off. Here's the original. Let's call this f of x. So you get used to that. Seeing that f of x is 3x minus 5. So if I switch the x and the y, so now I've got x equals 3y minus 5. If I switch the x and the y like that, and then I solve for the y, that's going to give me the inverse. That's going to give me the equation or the function that is going to undo everything that this function does. So just to show you that real quick, let's actually fill out one of these tables. Now look at these tables. Which one is supposed to be for the inverse and which one is supposed to be for the regular? So here's the inverse, right? So this is for the original. So let's go ahead and fill this table out using this formula right here. So I'm going to start off with some really easy numbers. I usually always start off with 0. 0 is the easiest because 0 times 3 is 0 minus 5. So y is -5. If x equaled 1 is always an easy number. So if x equaled 1, 1 times 3 is 3, minus 5 is going to be -2. If x equaled 2, well then, and again, if you remember this function thing up here, I'm just putting things into a function, and it's giving me numbers out. It's giving me out a range. Okay, so next number I'm going to put into this function is going to be 2. So 2 times 3 is 6, and this function gives me out a 1. If I put a negative 1, negative 2, these are usually the 5 numbers I use because they're always really easy. If I put in a negative 1 times 3 is negative 3, minus 5 is negative 8, and you can kind of see this common difference right here. 1 goes down to 2 by subtracting 3, subtract 3, subtract 3, so I'm guessing this is going to be negative 11. We can check that. Negative 2 times 3 is going to be negative 6, minus 5, okay, so that is negative 11, sure enough. Okay, so what we have done now is created a table of values using the original function. Now let's see if we can find the inverse. So again, we switched the x and the y, which is what we did right here, and we're going to solve for that y. I'm going to add 5 to this side. So I've got x plus 5 equals 3y. Now I'm going to divide by 3. So I'm going to have x divided by 3 plus 5 divided by 3 equals y. And once I get y by itself, that should be the inverse. This function is going to undo everything that this function did. So if it's going to undo it, there's an easy way to verify that. And it's the reason that we created that table. It should be able to take this 11 right here, this negative 11. I should be able to plug it into this function and go from this output and get that input. It should be the complete opposite. So let's try it. If I take negative 11 and put it into this function for the x right there. So I'm going to have negative 11. Let me square that off. That's the function. So negative 11 over 3 plus 5 over 3. And the thing is, what does that equal? Okay, negative 11 over 3 plus 5 over 3. Well, negative 11 plus 5 is negative 6. Negative 6 over 3 and negative 6 over 3, sure enough, equals negative 2. So notice this function took the output of this function and gave me back its input. And it will do it on every single one of these values. So negative 11, sure enough, did go to negative 2. Negative 8 will go to negative 1. Negative 5 will go to 0, negative 2 will go to 1, and 1 will go to 2. This function right here is the opposite. It's the inverse of this function. It undoes everything this function would do. Okay? So let's go ahead and look at this example real quick. If I was going to find the inverse of this function, again, all I have to do is switch the x and the y. So I've got x equals y squared, and then I got to solve for y. So to get rid of something that's being squared, you need to take the square root. Square root of x equals y, and anytime you take the square root, you need to make sure you put a plus or minus there. Alright, I'll show you an example of that later on in this video, I think. And it's going to be the inverse. So there it is. That's the inverse. This is the function that will undo everything that this function does. So let's look at some more examples real quick. Let's look at it graphically. So now we've talked about coordinates. Here, let me go back over here. Remember, for a coordinate, if you're given coordinates and you're asked for the inverse, you switch the x and the y values. And that's it. Simple as that. If you're given an algebraic equation and you're asked for its inverse, you, again, just switch the x and the y values. And you solve for the y, and that'll be the inverse. Simple as that. Okay, now let's look at it graphically. So we did it with coordinates, we've done it algebraically, graphically. So here's the original. This one's the original. So at negative 8 on the original, y equals 1. At negative 2, y equals negative 2. At positive 4, y equals negative 5. And at positive 10, y equals negative 8. And since the whole context of this lesson is inverses, it should be pretty obvious that when you see this 1, negative 2, negative 5, negative 8 like we got here, I'm guessing it's going to switch on the other side. And you could verify that by looking at these graphs if you want further. But I'm just going to go ahead and write this down over here. And the same idea is right here on the original. We've got negative 2. Negative 2 is going to be at negative 6. Negative 1 is going to be at negative 3. 0 is going to be at negative 2, and because this is a quadratic function or a parabola, it's symmetrical. So I know that that's the vertex. I'm just going to come back down, negative 3, negative 6. Okay, and sure enough, it's the same thing as this over here. And what they're trying to do is show you the concepts of an inverse, how all of my ranges and domains have been switched, right? The domain for this function is the range for this function. The range for this function is the domain for this function. Okay, so when you're looking at this, the next question on this worksheet says, what is the equation of the line of symmetry? Okay, well, let's draw the line of symmetry. Looks like it would be, so there's my line of symmetry for this one, and my line of symmetry for this one is the same thing. Okay, so that is a parent function. That is the linear parent function. Its equation is y equals x. And the conclusion that I hope you draw from this, and you can only do it, I only gave you two graphs, but if I gave you a function and its inverse and I did that 10 times, what you would see is every single one of those will be reflected across this y equals x line. It's a reflection across that line. This one is a reflection across that line. So graphically speaking, if you're going to find an inverse, you just reflect it across the y equals x line, or the linear parent function. What do you notice about the domains and ranges of the original function and its image? Well, again, the domains of the original function are the ranges of its image. The range of the original function is the domain of the image. So you've got this flip-flopping that's happening. It just flip-flops to get to its inverse. And you guys saw that when we did the coordinates earlier. Let's see, what else is going to be important on this? This is a really important concept. What actually qualifies a graph, right? Something that you've graphed, some line that you've graphed, as a function. Okay, so let me give you some examples right here. So if I draw a parabola, there's something called the vertical line test. And let's see if I can find, I'll just do it with a pencil. Okay, so the vertical line test. If this pencil touches this function in more than one place at any one given point, then it's not a function. Alright, so this is a function because the concept is every single input, every single x value has one specific output. Alright, so for example, if you look right here, my input is 2. So I'm talking about x equals 2 right here. And my output for that value is 4. Okay? So for every single input, I have one specific output. If I took the inverse of this function, it would look something like, and I'm just going to draw it over the top of this. And that's an awful drawing, but the concept is still there. It looks something like that. If I did the vertical line test, notice it's hitting this function in two places. So for any given input, I could have two outputs. That's not a function. All right? So that would be what a function would look like. Now, question, is this a function? Right here for number 4. It says that -3 is my input. So -3 is my input. What's my output for -3? -3 is my input. 12 is my output. Okay, that's fine. What about for -2? If -2 is my input, then it could be 12. However, it could also be 13. That's not very good. Okay, so if I have one input giving me two outputs, that's not a function. It's like walking up to a Coke machine and I press the button -2 and it gives me out both a Coke and a Dr. Pepper. So that would be a good day for me, but a bad day for the Coke company. So that's not a function. Let's look at this one. I think this one's a great example right here. All right, is this a function? So when I press the number 2, notice that I get a 4 out and I get an 8 out. So no, that's not a function. What about its inverse? Is the inverse a function? So to find the inverse, I just exchange the x and the y. Is that a function? So for 4, I get the number 2. And for 8, I get the number 2. That's fine. Again, it's like walking up to a Coke machine, and a lot of times, for the most popular beverage, they're going to have two buttons that will both get you a Coke, or maybe two buttons that'll get you a Dr. Pepper. This is like walking up and pressing the button number 4 will get you a Coke, or button number 8 will get you a Coke. And that's fine, all right? If you have two different inputs that give you a single output, that's okay. But you cannot have the same input giving you two different outputs, all right? So that's the concept. You can't have you can't have the same input giving you two outputs. You can have two different inputs giving you the same output. All right. Let's see. I hope I haven't been recording for too long. That'll do it. Okay, guys. If you have more questions, you can come into class and ask me anything you need. Come to my tutoring time. But thanks for watching.